Yeah.
All right. Let's make sure the controls are working here. Now, Steve, were you planning on doing a sort of an introduction to the slides, or should I walk through it?
I can do a brief introduction, I guess.
Yeah, not a problem.
Thanks, everyone. So this work is work done on the Exemplary Buildings program, which is designed to kind of prepare the affordable housing community for new requirements and code ahead, new technologies, and so on, and to build the best buildings we can. This series of workshops, and this being the first, is to really share the best practices, the promising practices rather, that we have started to uncover. We call them promising practices because it's a kind of a moving target and they will evolve over time. But one thing I want to emphasize before turning it back to Brad is that, and I think it's in the next couple of slides, so I'm jumping ahead probably, but that the exemplary building work is targeting many areas of buildings, and we hope that the community will take learnings and infuse them into your work. So you don't need to be designing an exemplary building following all the guidelines we've established for the demonstration projects we're doing, but the learnings that are coming out of it can be applied everywhere. And some of them apply to current code, and some improve tenant health, reduce costs, and so on. And I think the last thing I'll say is that our objective is to bring the best buildings possible to the affordable housing sector without compromising units produced. So essentially we're kind of, how do you build the best building and reduce the cost of doing so? And I think you'll see in Brad and David's presentation that is what we're trying to do. So listed here, you can see the other workshops planned, integrating solar with affordable housing, how to maximize the solar production cost effectively, a domestic hot water, early integrative design, how to pull it all together, and finally balance ventilation with heat recovery. So we look forward to you all joining us and spreading the word amongst your colleagues at these workshops.
Yeah, and I think we had previously, and for the future workshops, I think we were planning on having some interactive polls. Lauren, correct me if I'm wrong, but we didn't have that on board for this one, correct?
Yep, that's right. But we could, if you wanted to, take the temperature in the virtual room.
Yeah, I think we got a good sense from the introductions of everybody. It seems everyone's well involved with the affordable housing community. So unless anybody would like to add anything or have any questions at this point, we can move ahead. Just to give a little bit of background on sort of who's behind this. It's a large group of us that meet regularly, called the Exemplary Buildings Task Force. We're an interdisciplinary team, and as Steve mentioned, we're trying to develop some best practices for exemplary buildings, but also parlay that into improving the way that we build affordable housing units outside of our program. And that's a lot of the point here, is finding ways to harness efficiencies, do things that don't necessarily bog down the construction process or increase the costs or reduce the amounts of units that get built. And what we're trying to do with the workshops is share that with the community. So the wall assemblies was one of the first kind of guidelines we started working on. About this time last year in November, we gathered sort of a group of stakeholders within the affordable housing design, construction, and development community, and started to try and figure out, okay, if we're going to be changing how we build walls with either forthcoming code requirements or for in the future practices with higher R value walls, we don't want to have 100 different options for 100 different wall designs. Can we kind of whittle down some of the key ways to build walls and sort of almost get a ready kind of spec for starting people out on the design of how to build higher R value walls without having to reinvent the wheel. You know, there's a lot of guidelines. If you sort of start looking into how to build higher R value walls, you see truss walls, double stud walls, you know, all sorts of ornate wall assemblies, which are, you know, very valuable. But you know, we thought that whittling it down to some ones that are kind of not too different from how we build walls today might be a good kind of incremental next step in introducing higher R values into our wall assemblies. So the overall goals of the guidelines were that we wanted to make the walls as cost effective as we could. We wanted to keep things simple, use practices that wouldn't scare, you know, framers off or installers off from what they're doing already. We wanted to cover all of the like sort of typical walls that we would encounter on any given sort of multifamily mid-rise affordable housing project. So that's your wood frame walls, your steel stud walls, and your concrete walls. And we also wanted to make sure that we were addressing the sort of air control, water control, insulation, and the vapor control. So to give a bit of background, what we're shooting for as far as the performance targets of the exemplary building program is a little bit more than code, but not too far beyond the forthcoming 2018 code. And that's part of the intent, is to start kind of get that forward thinking out there, start laying the track towards the next code cycles. So one of the overall targets that we're going to be wanting to shoot for with the building is to improve the building airtightness to less than 0.17. Our current code at 2015 is 0.30, but we have a C406 or an energy code increased efficiency target of 0.25. So with the forthcoming code and with the exemplary targets, we're trying to ratchet that down and get the buildings a little bit more airtight. We're looking to have a little bit higher R value or lower U value out of our walls. I think our walls currently in 2015 code are about an R18. So this is improving the R value or insulation value of those walls. And then also trying to sort of dial in on ways to reduce thermal bridging and avoid having areas in your walls of high conductivity where you know, heat loss can occur or energy loss is easily transferred. So those are sort of the bigger picture targets that we're shooting for, and kind of looking at how that compares to the different code cycles. It's worth kind of walking through, because what we're really trying to pitch here is not too far beyond where we're going as early as next year. So currently, you know, if you're filing for permit today, which I think we've filed a lot for permit over the last couple of weeks now that we're nearing the end of the 2015 cycle. But if you're filing under the 2015, you need to put an R21 bat of insulation into your wall, into a 2x6 stud, and that gets you a U value of 0.054. And that's basically how we've been building walls for quite some time, since we switched to 2x6 construction. It's starting next year, or under the next code cycle, that's all changing. So we can no longer put a standard 2x6 bat into a 2x6 wall and comply with the code. We're going to have to do something else. So that's going to really sort of change and have us at least rethink a little bit how we're building walls, especially at a mass scale. You know, on a project by project basis, we'd had in the past seen some 2x8 walls. We'd seen some walls with a little bit of exterior insulation, but for the broad, you know, for every building now, we're going to have to start rethinking how we're going to do this. So now is a good time to get that process going. For the exemplary building specs, you know, that sort of incremental step further, we're trying to look at how we can take that to getting about R31 is as the bat insulation, and the effective R value, once you account for all the wood framing, takes that down, the U value down to about 0.045. So we're trying to figure out how to design a little bit beyond code, so that we can then harness those strategies for how we can best build to code as well. And we feel that's pretty informative. Looking at the building airtightness of buildings, there's sort of two paths for energy code compliance. And one is your typical path, but as every building has to select certain C406 additional energy efficiency options, there's always an option to go for increased air tightness. And that can often be kind of a low-hanging fruit as far as achieving that without having to pay too much additional costs. And we've done that on many affordable housing projects, especially because the ESDS sort of requires us, and sometimes funders also ask us to achieve more than just the original two C406 options. So this is one that's very desirable. That target that we hit shoot for under the 2015 code is 0.25 CFM per square foot. And that's going to be ratcheted down to in the 2018 code to 0.17. So it's an aggressive target for air tightness, but it's not one that we haven't achieved on many affordable housing buildings. We just have to be very careful with how we approach it. And that target of 0.17 is aligned with what the target that we put forward in the exemplary building specs. So we're trying to align that with the practices of the code, so that if you so that this can become an easier or a more regular option to be chosen among the additional energy efficiency options when it's somewhat baked into our standard practices. So I think I just talked through a good bunch of that, but I think the main thing is, and we sort of learned this quite a bit in the wall charrette, is that the biggest effect, I think, of the forthcoming code is that whether we like it or not, how we frame wood walls is going to change. And that's going to be an important thing. So we have to do there's kind of four sort of easy options to address the forthcoming code, whether it's just for straight 2018 compliance. So, one option is we do kind of a UA analysis of buildings. And that's one where we use trade-offs within the envelope or a performance model or an energy model to allow for slightly less insulation in our walls to make up for something else. I don't see that being a very desirable option under the next code cycle. I don't know what your thoughts are, David, but I don't see it as being that desirable for walls only. Walls are usually, insulation is usually a thing where you've got opaque walls. If you're going to do an energy model, or if you're going to do a UA analysis, you're not doing it so that you can put less insulation in the walls. It's typically to get more, more glazing or something else around that. Is that?
I would, so for most of the projects now, I believe, in my experience, are doing the trade-off approach.
Yeah.
Even for moderately glazed affordable housing projects. But this change will make it more difficult to comply, especially with some of the thermal bridging challenges that occur with the 5/1 and 5/2 kind of building types. So that it will, no doubt, it will be more difficult to comply with that approach. I anticipate it to be more just as common as it is now, for that reason, to be able to trade off. But I think there's going to be a lot of evaluation between sticking with 2x6 and improving, say, windows to compensate, or going to what you're talking about here, which is better opaque wall construction.
Yeah, because you end up not starting, if you go with 2x6 walls, when you're doing trade-offs, you end up not starting at the same starting point, right, with
Right.
your walls. So you have to take that trade-off from somewhere, and then it ends up becoming your windows or
Yeah.
or the roof. But there's different strategies, but it may not be it may not necessarily be the most common path, given that you already started that discounted option. The other option that we do see is exterior continuous insulation becoming more and more prevalent on walls. So you stick with the 2x6 framing, but then you add continuous insulation around. But that adds another step. It adds another trip around the building for a trade, and more things to install. 2x8 standard framing would be code compliant with the bat that you put in those cavities. So keep the same framing practices, but you're putting in an R25 bat, and that would comply with the 2018 code. But it does mean switching to a different type of wood. And then 2x6 with advanced framing, which is a big part of what we're trying to push with the guidelines. That would also allow you to still use the same type of lumber, still use a similar wall depth, but then you're just changing the way that you're framing out your walls. So last year with the charrette, we kind of started looking at these different options with a number of stakeholders in the community, and we learned a fair bit from from the feedback. I think a few of the big takeaways before we get into the guidelines that I wanted to summarize were, one would be that we're looking at steel stud assemblies, concrete wall assemblies, and wood framed wall assemblies, but what's most paramount and what's going to change the most is the wood walls. With the targets changing for steel stud and concrete walls, there's not really much else we can do but simply add a little bit more insulation. But with wood framed walls, there are different options because you get more value out of the insulation in your cavity. So getting the wood framed walls right is the most important thing, but it doesn't necessarily mean that the steel stud walls and the concrete walls aren't important. It's just there's definitely a weight on making sure that we get it right in the industry with the wood. What we kind of heard back from framers and GCs and contractors was that when framing a wall, it's still preferable, and especially as it becomes more common practice, it would be preferable to do 2x8 framing over top of 2x6 framing with exterior insulation. So there's certainly going to be cases where we're doing both. And I think the wall guidelines do show an assembly for both, but I think as 2x8 becomes more commonplace, that might start to evolve into the sort of go-to for how we frame our buildings. Looking at all of the sort of options or opportunities within these sort of changing wall designs for how we could have an impact on cost control, I think that really dialing in advanced framing techniques can have an impact, because it's kind of an aligned target between, you're making a wall more energy efficient by taking wood out of it. And wood and lumber, the prices are going up. It's a costly element compared to insulation. So sort of really getting the industry, moving it towards trying to get the wood out of the walls so that we can get better insulation is kind of a win-win in both scenarios. And then for the exemplary building targets, which are a little bit higher than code, blown in fiberglass is pretty promising. You can get more R value and you can get more insulation value within the same cavity as you can with just a regular bat insulation. We are seeing blown in fiberglass on some of our projects start to happen. We're using it on the DESC Hobson Place projects, and it's it will get you more R value in the same cavity. It won't quite get us to the point where we would be code compliant in a standard framed 2x6 wall under the new code, but it would allow us to use 2x8 framing and advanced framing to achieve the targets with the exemplary building program. So it is a way to kind of get better insulation in the same amount of space. All right, so I'm going to switch screens right now. Bear with me, everybody. Let me know if are you still looking at a PowerPoint, or are we looking at the wall assembly guidelines?
We see the guidelines.
Oh, perfect. Okay, so I just wanted to sort of walk through. So from the charrette, we ended up putting together some guidelines to assist with wall assemblies on exemplary buildings, and the intent is to have as much sort of pre-packaged information that you could then at least have it sort of, estimate ready, or ready as an outline spec. So on the cover is a sort of overview shot of some of the different practices we're hoping to incorporate, mainly with the advanced framing of the wood. We'll get into that as we sort of dive into the details. But just to give kind of a rundown of these guidelines, the way we did it was we did a sample wood frame 2x6 wall, a sample wood frame 2x8 wall, a steel framed wall, a concrete wall with exterior insulation, which we love, and a concrete wall with only interior insulation, which we love less. And then we had a couple concept details just to show some of the practices that we see improving thermal bridging. And there are also ones that we're trying to incorporate on projects, and then provided some additional resources that sort of help inform not just these guidelines, but also are very useful for use when designing walls. So I will move into the overall wall types here. So just looking at the sample wood frame wall, this is how we would get an R22 wood framed wall. And really, if we're going to be building with standard 2x6 studs under the 2018 code, it would be very similar to this, but with with a little bit less insulation. And that's also a pretty important thing to consider is, if you're building, insulation only comes in so many thicknesses, and you can get rigid mineral wool in 1.25 inches. And if you're going to be going around and putting, a little bit of insulation, it's very easy to use 1.25 inches mineral wool if you're going to do it anyways, and fasten right through it. It's thin enough that you can hold up the cladding. And this wall, we do show blown-in insulation, but it is otherwise not too different from an exterior insulated wall that we would see. There's a little bit added insulation because of the blown-in, and the mineral wool is on the outside. But if you're going to use standard framing in the next code cycle, you would need to be doing that exterior insulation anyway. So we felt it was important to have an option in here, or at least an outline spec for a wall where you're still sticking with kind of standard 2x6 framing. One of the things that we'll talk about is we did talk a little bit about in these guidelines about sheathing as well. Sheathing choice starts to become fairly important as we get to the 2x8 walls. Not necessarily because OSB is inherently bad, but it is a little bit more sensitive to water. And as we insulate walls more, we'll talk a little bit about how OSB is kind of something we want to just be a little bit more careful with, the more insulation that we're putting into walls. In order to achieve a steady or a fairly set ourselves up the best for getting that increased airtightness, we sort of put two options in here for how we can get our air and water barrier. And And these we've checked as far as given how breathable they need to be. But we'd also think that to get a building down to 0.17, if you're going to be using a fully adhered sheet, that sets you up better than the fairly standard Tyvek or Fortifiber or Vapor Shield sort of fastened approach. But we still can do that with sealed sheet if we do sealed sheathing behind it and still get very tight buildings. But there are some costs to that. With all that said, there are plenty of buildings that we've built in this marketplace that have still done a fairly standard Tyvek or Vapor Shield like air barrier approach that have hit the targets that we're searching for. But we do feel like these options will set you up a little bit better unless your design and construction team is really committed to sort of the sort of rigorous dialing in of the Tyvek to get to that 0.17 target. So that's a thing to sort of keep in mind. Is these are guidelines, but we feel like either of these two options would set your walls up a little bit better to achieve the increased air tightness requirements. Vapor barriers are another thing that we tried to spec out in our walls, and they do change sort of assembly by assembly. We're in a fairly mild climate where, if you go up to Canada, like even just up to Vancouver, they're putting sheet poly on the insides of all of their walls. But in our climate, if we have, for most of our walls, if we have any kind of exterior insulation or anything like that, latex paint is good enough. We often see vapor barrier primers and other things like that, but 2 coats of latex paint can be enough vapor control for many different wall assemblies in our climate, which we feel pretty comfortable with. The other thing on this standard 2x6 framed wall is you'll see that we showed just fastening through the mineral wool. There are a number of ways to do that, but we often do sort of cladding engineering work throughout the region, and we just put in a spec of something that will work so that you can kind of price it out up front by just using a certain density of mineral wool, number 12 fasteners at 16 on center, and then a minimum embedment, so that that takes away kind of a lot of the questions of, can we do this or how does it get done? There's also a lot of other information out there, but we just wanted to put something down there so that it's kind of already baked in, and it's got a wind load. So really, we're not seeing a lot of mid-rise buildings that have higher wind loads than what we're showing there. So we think that the furring attachment there is pretty bona fide. Where we do need to be careful though is fastening cladding, and that's another thing that we'll want to talk about on a case-by-case basis, especially when we get up to 24-inch on center framing. Fastening cladding when you have exterior insulation gets a little bit difficult because the stud's not right behind your fasteners, and it can be surprisingly a big driver of cladding selections and wall type selections, because there's only so big of a nail that can fit into a nail gun, and siders will want to use nail guns, and there's a fairly big construction cost trade-off that comes with having to screw in siding or screw in your fasteners, and that's also why kind of avoiding the exterior insulation and using things like 2x8 wall assemblies. There are some advantages when it comes to siding practices to having the stud right behind where you're putting your cladding system. So that's sort of the overview of how we would get an R22 2x6 wall. Looking over at a R22 wood framed 2x8 wall, it starts to look a little bit more familiar, just a little bit deeper, right? So if we have a lightweight cladding, if we have working in from that, this is the drawing and section, we've got borate furring. Ventilated rain screens become very important, or continue to be very important, but even more so with 2x8 walls. We still have our air and water barrier right behind it, our sheathing, a deeper stud. In order to get up to R22, we would do advanced framing with R31 blown-in fiberglass. If you were going to be going for straight code compliance, this could be done with standard framing and a standard bat. Though that would really be the only difference between a code compliant wall and the exemplary buildings guidelines. Some of the additional considerations are that we sort of put into the guidelines are to try and, build on a 24-inch grid, locate within your windows within the stud spacing module, try to eliminate the rim joists, maintain the use of a double top plate. The double top plate, we can talk about it a little bit later, but some guidelines for advanced framing that are more geared towards single family homes are looking for a single top plate. But feedback we've gotten from framers and from structural engineers are that try to keep that double top plate in our market. Just for the multi-family buildings, it keeps the keeps everything better aligned and more stiff. Try to place some limits on your window and door openings, and then try to platform frame your parapets. And a lot of these items are things that we're trying to achieve on many of our jobs as a matter of course, but it's good to sort of have these in here because a lot of the assumptions that go into the walls are based on doing some of these things. The air and water barrier options still remain the same as the prior and actually end up being sort of the same throughout all of these walls. What ends up happening with a 2x8 wall, and this is something that should be considered, and if there's time, I'll talk a little bit more at the end, but this is the assembly, the 2x8 wall assemblies are where we want to be a little bit more sensitive with our vapor retarders. This is probably the only one where you wouldn't be able to get away with simply 2 coats of latex paint. The reason for that is there's a lot more insulation and the sheathing is a little bit colder. Another thing to keep in mind with the 2x8 walls is that there are a lot of spots where we're building buildings in Seattle that are on hills. And those spots, there are very limited amounts of ways to attach fiber cement panels on 24 on center. And I'm thinking places like Yesler Terrace, for example, because of the hill escarpment there, you get actually pretty high wind loads, and there can be challenges anchoring certain cladding types, primarily fiber cement, on 24 on center due to the limitations of nail gun lengths and the higher wind loads that you would achieve. It's mainly in corner zones, but it's something that we would recommend keeping in mind kind of earlier on in the design phase when you're kind of picking or deciding on cladding locations, that those corner zones, those outside corners of the buildings are a little bit more susceptible to wind when you're building on 24 on center. Another thing to keep with this is we've sort of validated all of these assemblies with a model, a WUFI model or a hydrothermal model that sort of measures the expectations of moisture in the sheathing and other components of the wall. And these are fairly robust for standard conditions, but if we do have high humidity conditions, you'll just want to have your team take a closer look at the wall assemblies. Because high humidity conditions these walls can be a little bit more susceptible. And that same goes for 2x6 walls, but 2x8 walls are just even a little bit more a little bit more prone to moisture than their predecessors. So where things look fairly normal, but just with more insulation, is when we're trying to get an R22 steel framed wall. You really don't get a lot of benefit by going with deeper studs, just because the steel is so conductive. So what we do here is we would actually just increase the amount of insulation on the exterior. There are options that we baked into the guidelines to either use fiberglass clips to attach your cladding, or mineral wool of a certain density and a fastening pattern that you can just fasten right through. This goes right back with vapor retarders, right back to the same approach as any other standard wall, which is just latex paint would be fine. And we've got baked into the guidelines some ways to attach furring so that you can sort of get estimates on how that would price out. So we also have two exterior, an exterior insulated concrete wall and an interior insulated concrete wall. One of the things that we've done with the exterior insulated concrete wall was try to limit the amount of insulation on the outside to about 3 inches. And so if you're building a code compliant wall with insulation on the outside, you'll want to keep about that same as well. The reason the 3-inch kind of works really well is that with 2x8 wall construction, you can often hang your 2x8s over the slab edge 2.5 inches, and then you add in your 1/2 inch for furring, and you get some alignment between your face of insulation with the face of sheathing as you transfer across from your podium up to your walls. So then you don't end up having a bump out between your framed walls and your concrete walls. We did give one of the things that we like with interior insulation is the use of non-halogenated polyiso. That's sort of a healthier building material. It's red list free. It's better for ozone depletion, and it's a little bit better than using a lot of the other kind of board insulations that we'd normally put on the inside of concrete. We also, in the guidelines, have a concrete wall that's exposed on the outside. We're trying to avoid this, and I think the way that the 2018 code is moving, it's really going to disincentivize the use of exposed concrete, which is something that's going to be important, mainly because they're going to have you align your windows and openings with the insulation. So if you've got concrete walls and you're putting your insulation on the inside, you're going to have a very deep recess for whatever windows or storefronts or anything that you're putting into those openings. So having a little bit of exterior insulation on the concrete is going to become a little bit more desirable, mainly because it'll allow you to sit the windows properly into the concrete openings and not have them pocketed so far deep. And it's a prescriptive requirement in the forthcoming code for the window placement, so there's not really going to be a way to get around it. So just a quick axon on the advanced framing. And I'll just kind of walk through some of the characteristics. And this detail actually sort of shows what we're looking for at kind of each of the different approaches. So as we sort of mentioned, that 3-inch insulation down at the slab edge allows you to overhang a 2x8, 2.5 inches. And if you have 3 inches of insulation, things start to align. Obviously there's ins and outs with any concrete, but that allows you to get that sort of continuous cladding face down the vertical front. So it's kind of baked in by getting the assembly right down here. You can tie in fairly easily at your slab edges. The modified platform framing is a thing that we feel is pretty intriguing because it eliminates rim joists and is actually safer to construct. It's something that is commonly done down in Oregon that I think is a pretty promising practice for up here. And I believe it allows us to get more insulation up higher into our wall cavities so that we can eliminate thermal bridging across that across that floor line. It also allows us to save on the wood we're using, because we then don't have to have our engineered lumber or our big 2x12s that's at our rim joists. I think Scott and David will talk a little bit about how you guys are intersecting intersecting walls is a kind of a real challenge with advanced framing, because I know trying to keep continuous insulation across those walls can be a challenge. So a 2x4 on the backside or ladder blocking, a few of those options on the inside might be ways that are achievable. 2 stud corners are kind of what the code calls out for advanced framing. Outside corners, it's fairly straightforward. So you got a 2 studs and then a drywall clip on the inside. At inside corners, getting a 2 stud corner can be a little bit more challenging. So there's sort of 2 ways to do it. One is to panelize, and that means running your sheathing kind of in first, and that sheathing would run all the way to the inside corner of the wall. But then the other option is to do what's called a California corner and just use a 2x4, because you need to pick up this sheathing board somehow. So you either run that outside sheathing all the way to the inside corner, or you pick it up with a 2x4. What we're trying to avoid, though, is having another stud right there to break up the bats. So the California corner here would allow you to still bring the bats kind of all the way through. And this is sort of a detail sketch that can be used as a basis for how to do the modified platform framing. So there's 2 different sort of sides. There's where the joists are running into the walls, where you have hangers, but then where the joists are running parallel to the walls, where you'll need some side blocking for wind resistance, and that'll be sort of designated by the structural engineer. Sometimes it's 1 bay, I believe sometimes it's 2 bays, but you can see here it allows you to run the insulation up higher, and then instead of a big kind of thermal bridge at the floor slab, you then just have just a little bit more. The other thing that this really helps with is from a cladding perspective. There's really then only 1 spot to break your cladding. We often run into jobs where you're trying to run a single piece of cladding from one side across the floor line down to the bottom, and you can run into some challenges with that. This simplifies that by making the floor line break at a very distinct spot. And if you've got a cantilever, your cladding, it becomes a little bit easier to do that. Platform frame parapets are another good way to run the air barrier underneath your parapets. And this is a way that really helps us when we're trying to get our buildings to the types of air tightness we need. And it allows you to just have continuous air tightness below. Just kind of show you how that is. So you run your air barrier this way instead of over and above. And that prevents air from getting up in here and moving all over the place. And we've just found that doing this is a fairly straightforward way of getting better bumps on your whole building air tightness test. And this is a section look at that alignment of a 3-inch insulation thickness with a sheathing thickness to allow your cladding to plane out. And this is the same with 2x6 walls, and the 1.25 inch insulation still planes out the same. And these are some very, very helpful guides on a few of the additional information for diving deep into how to build higher R value walls efficiently. And that's sort of what's baked into the guides. And I'm probably going to switch back to the slideshow. And I think at this point, David and Scott are going to speak a little bit about Sawara.
Yeah, thanks, Brad, for running us through that. So the Sawara case study that Scott and I are going to be talking about here is the first exemplary building demonstration project to take these guidelines with focus on the advanced frame 2x8 wall and implement them into their project. There's a couple of reasons why that was possible. Mainly, I would say the owner's commitment to the EV goals and interest in doing this in their building. Tom Eanes at SHA was very he pushed the team to look at this, and then Scott's leadership through the integrative design effort was critical. Bringing together the GC, the structural building envelope, and us, the energy consultant, to look at these requirements and how they the trade-offs and really think it through, which is really what we found is needed to make this successful. And of course, MARPAC doing cost estimating and thinking through the challenges of construction for, in this case, the effort was to compare the costs and constructability considerations and performance trade-offs of the 2x6 with exterior insulation that in the guidelines that Brad described, and the 2x24 on center wall. So if you can go to the next slide. I just assembled a table of kind of my thoughts, and Scott and Doyle from MARPAC. We had a discussion yesterday kind of talking about what really led to the decision, or informed the decision at least, for the team to make the leap to the 2x24 on center, was just what are the trade-offs between these two wall approaches, not just cost, just all these other things, and that do ultimately can have a big impact on cost. So to kind of run through the ones that came to mind, one was just how do we achieve this 24 on center goal? It really took a lot of discipline, from what I could tell, to lay out a grid on this project. It's not a straight rectangular building project. It's complicated. It's got multiple kind of portions of the building that are connected by breezeways. So it took a lot of discipline to lay out that grid and achieve those goals of locating windows on that grid, the wall modules, and which wouldn't have been required with the 2x6 approach. The sheathing. So fortunately for SHA was already committed to using plywood. So that was assumed for both the cost estimates. And ultimately, and I hope Scott maybe can speak to this more, just how the plywood did play into the cladding attachment strategy for which is going to be assumed to be at 16 on center, with some locations not being on the stud, at the stud connection. Shear walls were all moved to the interior walls to eliminate the stud packs in the exterior walls. You mentioned the rim joist. That does play into eliminating an extra insulation step on the rim joist and better overall thermal performance. And so this project will be implementing that advanced platform framing concept. The exterior insulation really was what MARPAC identified as a real sequencing and time planning consideration that probably wasn't completely built into the initial cost evaluation, because the 2x8 did come back lower without totally accounting for that. But it was a real, once you start thinking through these details, Doyle found it makes it less of a known quantity. The thermal performance, we are aiming for this R22 overall. Both were cost priced. We believe to be approaching that. The 2x6 wall, I believe, was priced with using green girts instead of nailing through the continuous exterior insulation. I think that was not. It was not known that was the alternate would be acceptable for this project. So I think we may be not comparing the price. The pricing wasn't maybe directly aligned with the exemplary building guidelines, but pretty close. And it's still a sequencing concern. So overall, just I think the team found that the 2x wall was less cost and more of a known quantity when it comes to project schedule and other details. So that was the direction the team went. Scott, do you have anything to add on?
Yes. Thank you, both Brad and David. The guides that were assembled were extremely helpful and useful. The early integrated design process was a critical component. MARPAC, RDH, O'Brien, PCS Structural, we had been tracking this question kind of in the middle of SD. We are 114 units, type 5 over type 1. And each discipline knew that we had kind of a summit conference call where we were discussing the issues. I've been a big fan of outsolation for a long time. I think the tipping point became, I never thought we could do 2x8 with advanced framing and make it work. The key elements were just almost as a matter of course for us is setting up the building on a 2-foot grid. And as we were working through the different options, the key became, can we reduce and be disciplined in as few studs as possible on the exterior walls? The more studs that we had in the 2x8, it kind of favored the outsolation. So that was just critical. We're not absolutely perfect. We have a few bays on the west side, and we're going to be working with MARPAC on plan details for the studs. The stud corners, very, very important. And we are working on where the ladder is, where the perpendicular wall comes into the exterior wall. And the process, I've been working with Doyle at MARPAC, going, Doyle, I want to talk to the framer. I want to make sure that this gets executed properly. And I think that piece is really, really important. Sound also plays into it. We're in the Yesler Terrace area, and we have I-5 immediately or close adjacent. We took the sound issue to a certain level. Our acoustic consultant said, you're very, very close, and it was going to be a much deeper dive into research between the outsolation option and the blown in the 2x8 advanced framing. It's great. The early integrated design process, working with everyone was fabulous. We've got some details to continue, but that coordination, I think, is going to be essential to execute this.
Thanks, Scott. Yeah, can't emphasize that integrative design process being so critical to this. Brad, can you advance the next slide? And this is just kind of to try and illustrate that grid approach that how Steve and his team were, or Scott and his team were successful on implementing this. And it's not, if you look at the facade, it's really actually hard to tell that this is all 2 foot. And Scott did keep the windows to 6 feet or less. So that was another goal of the exemplary building guideline. Go to the next slide. Oh. Did you have anything you wanted to add there, Scott?
Well, it's just interesting. It's a U shape. We don't have an overall plan for you to see, but there are two pods on the east side that are almost square. And that was because of our number of 3 bedrooms and 2 bedrooms. And we were maximizing the corner opportunities. It has a long form on the west side that is mostly 1 bedrooms, but we had to come back and tweak some of the windows, but we were able to make that work on the 2-foot module. That's all.
And then this is just an overall, Scott mentioned all the team members that were critical to the success. I mentioned the green gird that may have changed the cost comparison a little bit better, or to make the 2x6 a little bit lower cost, but Doyle seemed to think that it was still the 2x8 was the best, the most cost effective. Scott mentioned that the walls will be panelized, and there's a sense that that is going to be really critical and useful to achieving this goal, because there's going to be less changes. There will be changes in the field potentially, and then the advanced framing. From an energy perspective, what the result is the wall, using that wall system with a modest glazing percentage. Basically, triple pane windows were not required, or higher performance windows than your standard double pane were not required to achieve the overall 20 UI target that the Exemplary Buildings program is outlined. And there's the walls don't affect all of the energy use of the building. It's a fairly substantial part, but there's a lot of other pieces to that 20 UI. But I do believe that this approach would, and we can look at this a little closer, would be compliant with the 2018 code, for example. So as the codes get more stringent, advancing the wall system, improving that, and may negate the need to move to higher performance windows than what we're using now for just a code compliant building. So that's all we have on Saguaro. Brad, back to you.
David, yeah, and a question on that. It's something that might be worth looking at is when doing the advanced framing, with what glazing percentage you would need in order to hit that, that like advanced framing with 2x8 and blown in bats. Mm-hmm. What like percentage of double pane glass would we be able to get and still hit that like C406 target for 15% improved envelope? Because that'll get more weight in the forthcoming code too.
Yeah, that's a balance that we're looking at. From a total energy perspective, more windows is not helping. Right. But from a code compliance perspective, it can, because it's oftentimes easier to get a better window and get credit in that portion of the component approach. So it's a little bit backwards in that respect. But if we're just looking at overall energy performance, this project I think was hovering right around 20% or 21% window area in the wood portion of the building, and that the more I think it's clear that the more window area you have, the more openings you have in your walls, and the benefits of, say, advanced framing and a better wall performance are diminished, and you want to focus more on your window performance in that case. But if you can get a lot out of that wall if you are hovering around 20%.
It was interesting for us balancing the window percentage with the windows on 2-foot centers. There's times we might have used a smaller window to reduce our overall glazing percentage, but the discipline with the 2-foot module, no, instead of a 5-foot 4 window, we had a 6-foot window. So we had to balance that out.
Awesome. I added a couple extra slides, but looking at the time, we've touched on a lot of these items. So I'm going to sort of, knowing that we're passing through, I'm happy to talk on these afterwards. But I know we're sort of running past an hour now. So I will summarize and basically, one of the things to keep in mind with a lot of this approach is that you don't change out your walls and through the life of a building. They're a very expensive thing to retrofit. You really want a wall to last 50 plus years, and so getting these right is important because there's no do-overs. Another thing is that with the new code coming, we are changing what we usually do with typical walls. So this rethinking is going to be really important to make sure we're doing it right, but also controlling costs, because any kind of change kind of disrupts pricing. So the guidelines are starting point for affordable walls, but then also a sort of a trailhead for trying to improve the insulation. And we think that these can be applicable for buildings, not just in the exemplary building program, but beyond that. And I think if anybody has any questions, now is a
Brad,
good time.
one thing I would add is, Scott's involvement in the wall guidelines charrette, and also your development of these guidelines. The document itself was, I think, really critical to this, because your guidelines are published right at the time that Scott and his team were jumping into this, and so everybody had a visual and a document they could reference for trying to understand what we're talking about here. So I appreciate that effort to get that out in time for this to be done.
Yeah, I mean, a lot of the info that's out there is, I mean, there's already such a good amount of info, and because Scott, you were involved with orchards, correct? At Aranco?
Our firm was, absolutely, yes.
Yeah, and so your team's work down there kind of laid a lot of groundwork, and some of the studies that came out of that were very helpful in sort of giving us the basis. Portland's a bit different of a climate, but allows for sort of the groundwork to kind of figure out, how risky these walls are as far as moisture goes. And yeah, it's exciting. The charrette was very, very useful, and I'm glad this has been some benefit. And Scott, I think your insight on a lot of these items is very important, especially some of the stuff in the slides and the things you're working through on the the layouts and the some of the trade-offs. So it's really important to for us to I learned a lot just getting some of this feedback today. So thank you.
Well, thank you. I'm a bit nervous. Hopefully a year from now, as we start construction and how we execute everything and how well we detail everything meets up to our expectations. So I think that would be a good follow-up.
Yeah.
Now, they're panelizing those walls, was that sort of because that'll allow you to get that 2-stud inside corner. And the other thing I saw, is the plywood on the exterior, just as a basis. The cladding attachments at 24 on center is very limiting, and that really frees you up. It seems like that really resolves that kind of concern, because then you're still laying your furring at 24 or at 16 on center then.
Correct. It really did. And that was the owners. And I like what David said, the owner's commitment, but they just want plywood on the exterior. Being able to bring the shear inboard to eliminate the hold downs and the stud packs that they take up on the exterior wall was critical, and the plywood was absolutely critical for the connections of our, for the most part, on the upper levels, hardy.
Right.
Yeah, I do want to, we do have questions in the chat. I do want to mention one point on the cladding that was, I thought was really interesting to learn, was that when Mark Pack looked at it for the hardy using panels, 24 on center attachment, Scott, correct me if I'm wrong, was possible if the thicker hardy panel was used, the 7/16 hardy panel.
Correct.
But that when combined with the use of the hardy flashings that were required with that thicker panel, really added, I think Doyle had mentioned it doubled the cost of the cladding system to go with the thicker panels. And so using plywood in 16 on center was critical to keeping the wall cost down. So maybe we can hit these questions, some of them which I think we may have hit, but Brad, do you want to?
Yeah. So Marty had a question about installation quality control using bat insulation. And I think that's an important one, especially when going to advanced framing, if you have to use ladder blocking, and if you have to get grade 1 insulation, because there's been projects where a grade 1 insulation requirement has prevented us from doing ladder blocking because bat insulation just bridges over all of that stuff. But if you have to add ladder blocking for partitions that are coming into walls that don't lat on the studs, the blown in can allow you to just get that much better insulation compared to bats. And I think that, even though the R values on the packaging between a bat insulation and a blown in bat, don't necessarily make all that much of a difference. I think the installed performance of blown in bats is much better because you're truly filling up the space.
Mm-hmm. Mm-hmm.
Agreed.
We had a question from John Hall regarding the advanced framing, and yes, I mean, I think we can all share that there is pushback from structural. We're doing one 2x8 in advanced framing with a project. I believe it's the DESC project at Bitter Lake, and we're seeing the comments back from structural are not too like. I think some of the feedback we've gotten was making sure we maintain that double top plate. The corners, the 2 stud corners, didn't seem to be too much of an issue, and the 24 didn't seem to be too much of an issue. I think, Scott, I think you guys resolved it quite well with just not making the exterior walls the main load bearing walls. What else have you encountered?
That's primary. And at times I remember calling structural, are you sure we're going to be able to do this? But again, if we had a overall building plan, you would see our U shape and how the majority of the floor joists are running parallel to the length of the building to have our bearing on the short sides. And throwing a lot of the shear on the inside, along with the unit demising walls. I think our maximum is probably, well, we have some in the bigger bedrooms, but in the 1 bedrooms, they're 12 feet or so for the span. So a lot of that helped reduce some of the load that we threw to the exterior walls.
But I think that is an important question, though, because it may also be the case that depending on configurations and certain requirements that, advanced framing may not necessarily be for every building. And that's why it's important to have an outsulation option, to have different tools in the toolkit that we become familiar with. I think the next question was, a vapor retarder on the inside face? Yes, that's a good question. So our climate, the only assembly where we really required like an actual vapor retarder sheet was when you do the 2x8 with blown-in bats. And even then, depending on your your interior humidity, there's a little bit of it's a bit of a gray area. Most of the other assemblies in our climate, if you have outsolation in any sense, 2 coats of latex should be enough, provided you have some level of insulation on the exterior and you have ventilation in your rain screen. Another thing that is worth kind of parlaying into sort of the future workshops is that as we insulate our buildings more, controlling interior humidity, or at least being able to help reduce humidity with some heat recovery ventilation, is going to be important. Now, not that it actually controls humidity, but not trying to avoid getting large amounts of buildup of interior humidity is going to be important. Our sheathing is very sensitive in this climate already. It spends a good amount of time on most walls with elevated moisture just on a regular basis, and adding more insulation will make them dry out a little slower. So we do have to be careful on the balancing of the moisture in our walls.
Hey, Brad, I saw kind of jumping down to the bottom, John Hall asked about that hardy cladding attachment that we talked briefly about, and maybe that's something we need to follow up on with Doyle. Doyle couldn't make this call, unfortunately, but
yeah,
I'm sure, Scott, you're tracking this cladding attachment question through.
It's an excellent question. We're in process. This is part where I was saying, I hope, everything we've laid out is going to be executed properly. John, when you experience this, I mean, I'm kind of banking on the plywood on the outside to distribute that load of the furring strips at 16 inches on center. Anything you can share about how you've experienced this, and I think would be great.
Yeah, that's my understanding, my approach. I've always presumed that the plywood should be able to take the load, but I've gotten pushback from Hardy, and I've also gotten pushback from siders who say they're nervous, and so they end up throwing in extra blocking, even though it doesn't seem like it should be needed. So it's something that should be tracked down.
Agreed. And John, there's, depending on where we are, where the projects are in the city, there are places, like, it's basically as long as your topographic factor in your wind loads is basically standard. So you're not, and so there's, like the north end, for example, you can space furring at 24 inches on center with Hardy panels and still use nails. It's really once the wind loads start to climb on the hilly areas of the town that you'll want to be looking at 16 on center. There are, even with the elevated wind loads though, there are still, I believe, some arrangements that will work with screws. It's just that slows the install process down. So that's why there's a big benefit if you can get plywood to go to plywood. And then usually the between your 1/2 inch plywood and your 1x3 furring, as long as you structurally attach the furring, then you use the full 1 inch embedment into furring plus plywood to do a sheathing only attachment. That's just something you'll want to check with, whether it's the envelope consultant or the cider to make sure that that's okay, because Hardy doesn't necessarily sign off on the attachment of the furring back to the sheathing, but we've done that in cases where we've had to make it work, and it works out.
Another scope gap that typically happens is we typically don't have our siding engineered.
Yeah. Yeah, and generally with that kind of stuff, we've at least given some sort of, like, we'll try to fill that gap whenever we can if it's a straightforward question like that. And I think that's also been part of the intent with the guidelines is I did try to put in some, you know, you can't engineer every case in a guideline because that would be irresponsible of me. But I did try to give like a fastening pattern for each wall assembly that should work in most instances. So then that way the sider can at least look and be, oh, if I use, you know, 12s at 6 on center here, I can go at 24 on center up to, you know, whatever the structural drawings let me know. And that way that's baked in without having to engineer your cladding.
I saw a question about using zip sheathing from Matt. I haven't run into that locally. Have you, Brad or Scott or anybody else?
So I have opinions on zip sheathing. And it's, you know, it's got its places. I try to avoid using it on projects. It's got, you know, the pre-applied weather barriers. They're becoming more and more prevalent. We're seeing them more in commercial construction with the pre-applied weather barriers for panelized walls on other systems. But the Huber zip sheathing, you know, it is in the Seattle area. It does raise a couple red flags for me. It's not saying that it's necessarily wrong to use it or anything like that, but I do try to avoid it mainly because it is OSB, and the taping and sealing of the joints is it's kind of a little out of sequence for what we would typically do. Yeah, we have had projects where the client has wanted to use it, and we've still put a weather barrier over top of it just because of concerns.
And then Marty, you know, Scott, you talked about a little bit about leading all the parties through this. You know, I guess, is there anything you can think to add of?
I think
it's important.
just, I think everyone really wants to be a part of a high performance building. And I think the early integration, and I'm absolutely in need of the expertise of the different disciplines. I personally enjoy the choreography of getting all that to work together. And with a lot of communication and a great deal of respect and involvement, it does create a culture of, yeah, let's figure this out. Let's see what we have to do, especially when it's early enough and the contributions can come in and get heard and get integrated. So I think we've been able to create a really good team on this SHA project, and Ecotope has been fantastic, and David, your group, and MARPAC. That teamwork is wonderful and very important.
Well,
Excellent.
Yeah.
Let's see here. I think that is the end of the questions. The Zoom poll is not functioning this round, but we will be doing it for future rounds. And Scott, it looks like I neglected to get your contact info on here, but we'll make sure that everybody's got it as well.
Okay,
and I just
great.
want to say, I think, you know, thank you to everyone on this, and, you know, thank you all for your input. And, you know, we hope to keep the conversations going. So always feel free to reach out. And I think, you know, the wall guidelines are a, you know, version 1.0, and there's going to be a lot of lessons learned that come out of some of the pilot projects that we're hoping to kind of be able to put back into the hopper and bake into an updated version in the future.
Great.
So are we-
Thanks, Brad.
Thank you. All right, I'm going to stop share now. That's all right. Okay.
I've got a toddler next to me that may make some dinosaur noises, but I think we're kind of at time here, and we were going to spend a little bit of time going over the preliminary energy studies for the exemplary buildings demonstration projects. I have it in a link here that I can share with folks if they're interested. I want to make sure that you do know that this has not been reviewed or approved by Seattle City Lights. So, these are preliminary, and some details may change, but I can share it with the group. And then I think what we might do is just kind of punt this update until the next time, unless Marty or Heather or David, you have a preference on that?
No, I think that makes sense to me.
Yeah, I'm fine with that too. I think the important thing we wanted to get out today, other than the actual results, is just to make sure you can see that the discipline around this exemplary buildings program that many of you have helped spawn here is really grounded in data and research, and we're doing our best with the group to track that and all these promising practices all the way through. So I will just conclude by saying thank you, and Lauren, you can take it away to finish it off, but remind people to go look at the Exemplary Buildings Program website. There have been some recent structural changes to it and things added, and it will be the place where all of these promising practices will be shared. Certainly going to get some quotes from Scott about the kind of leadership necessary to make this integrative design stuff happen. So thank you all for today. It was great.
Thank you, Marty.
Yeah, thanks for hosting.
Thank you.
Yeah.
Thanks, everyone.
Thank you.